The next group after the transition metals, we have the boron group. The boron group is located in the right side of the periodic table, and it includes the elements from boron, okay, over here in the periodic table, from boron passing through aluminum, gallium, indium, thallium. They do not occur in nature as free elements. If you're going to find them in nature, they're going to be combined in another compound, okay? Combined in different compounds. Remember that you must keep your camera turned on. Thanks, Steven. Now, another characteristic that they have is that they are scarce in nature, which means that they are not abundant, okay, except for aluminum, which is the most abundant metallic element on Earth, aluminum. But the rest of them, they are scarce, okay? They are scarce, and in the end, that is what is going to make it not just difficult to get, but also more expensive. Now, what do they have in common? These elements from the boron family, they consist of atoms that have 3 electrons in the outer energy level. So, again, if we do the electron configuration of these elements, you will notice that in the outermost level, they have 3 electrons. For example, boron, in the outermost level, they have 2s2, 2p1. In total, you have 2 plus 1, 3 electrons in the outer energy level. 3 electrons, okay? That is a characteristic. Aluminum, 3s2, 3p1. Again, 3 electrons in the outermost level. Gallium, 4s2, 4p1. 2 and 1 makes 3. 3 electrons in the outermost level. We could continue say indium, 5s2, 5p1, and thallium, 6s2, 6p1. All of them share the same characteristic that they have 3 electrons in the outer shell. They are metallic solids, okay? All of them except boron, they are metallic solid. Boron is not a metal. Boron is a metalloid, okay? But with that exception, the rest of the elements are metals, okay? So, boron is going to exhibit metalloid properties, while the rest of the elements, because they are metals, they're going to be sharing characteristics of metals. So this characteristic we already discussed about. Another characteristic that they have is they are quite soft and have low melting points, except boron. Remember that boron is like the exception of this group, but still is part of the group. Boron is hard and it has a high melting point. So with I want you guys keep your periodic table with you and see what is the melting point of boron. What is the melting point of boron? Remember, see the key so you can see where the melting point is located. 2030. Those are Celsius, okay? Degrees Celsius. Those are, I mean, that's a lot, guys. That's a lot. Now, see the melting point of aluminum.
660.
660, a lot less, as you can see. Yes, boron, it has a really high melting point. What about gallium? What is the melting point of gallium? I mentioned it yesterday.
29.8.
29.8 degrees Celsius. Do you know what is the normal human temperature, by the way? I mean, how can we determine if we are sick?
36.
36, okay? 36, 37, that is the normal temperature of the human body. Take a look at the temperature of gallium. It's 29.8. It's less than 30. That means that us, with our normal body temperature, we're going to be able to melt gallium. And this is what happened in the figure that you see right here in the bottom. Okay? Take a look over there. It says, the warmth of a person's hand will melt gallium. Gallium metal has the lowest melting point of any metal except mercury. I mean, mercury is liquid. It's liquid at a really low temperature. Temperature where we find ice, well, mercury is still a liquid, okay? But in gallium, in the case of gallium, when it reaches a temperature of around 30 degrees Celsius, it's going to melt, okay? Because that is the melting point of it. And it's quite funny to play with it. So it's a fun element. I like it a lot. One of my favorites, by the way. But it's expensive. Because, as I said before, it's not like aluminum that is a very common element. No, it's not abundant. Okay, they are scarce in nature. Then in indium, what is the melting point of indium?
156.2.
Still, this is a low temperature compared to boron. This is a really low temperature. Okay, and in thallium is 300 something.
303.
303. So you notice that they share characteristics of a low melting point. Even for aluminum, 660 Celsius degrees is a quite low temperature. But boron, 2000, now we're talking about really high temperature. So it is required such a big temperature to melt boron. They are soft. Okay, this is the characteristic that I just mentioned. And And the other characteristic that we have here is that they are chemically reactive at moderate temperatures, except boron. Okay, so maybe for us to see a chemical reaction between them, you will need to apply a little bit of heat to the reaction for it to be fun. Now, I wanted you to see this picture over here. It says aluminum is the most abundant metal in Earth's crust. It exists in nature as an ore that is called bauxite. In Spanish, bauxite is known as bauxita, and it is a mineral, okay? It is a mineral. And that mineral contains aluminum. So what happens? We have this ore, this bauxite, and we need pure aluminum for many stuff. I mean, for soda cans, for example, to aluminum foil, we need the pure aluminum. So to purify aluminum, it needs to undergo into a chemical process. Well, not just a chemical process. I mean, there are physical processes like extraction, like taking off the debris how do we say this? Debris or impurities that are going to be a part of the ore, of the bauxite ore. So what's going to happen is, because it needs to undergo into a chemical process, you will see this process in a video. I wanted to show it to you because two reasons. Aluminum is one of the metals that we are like always in touch with. I mean, even your sandwich, you pack your sandwich in aluminum foil. So I'm going to show you a video where the extraction of aluminum is done. Okay? Okay. Let me project it. Turn the cameras on. Valeria. Okay, this is a spot from a company that extracts aluminum from bauxite. Okay, and this company is huge. So this is I'm going to show you this process, the process that they use. Okay. First of all, they want to know where the bauxite deposits are around the world. So this company is so big that they have their own satellite to identify, okay, those bauxite deposits. Once the satellite had identified a spot where the bauxite is located, they're going to go to the field, okay, in the field and explore this bauxite, okay. After this, after the bauxite has been examined and they see that has a good quality, they begin with the mining process. To have a better extraction of the aluminum, they need to crush those bauxite, okay, the big chunks. They're going to reduce into powder. In that way, you're going to guarantee the extraction of the most amount of aluminum from there. So if you ever wonder how they do to transport, okay, that's exactly what they do. That's big. Thankfully, because of the Archimedes principle, this is possible. Okay, Archimedes principle is a principle that is used in fluid mechanics, and it allows us to, well, basically to float. Okay, the floating principle is Archimedes principle that we see in physics, by the way. And you can see that the transportation of this bauxite is, that's huge, guys. I cannot even picture a number of how expensive this is. As I told you, this is a really huge company. They can do it. Okay, this aluminum is extracted by a chemical process that is called electrolysis. Okay, so here they managed to tell you that that they reduce the energy consumption and they are eco-friendly because of that. But I just wanted to show you how this aluminum is extracted from, from the mining process, even from a satellite. That's how it started over there. And here I have another video where this extraction occurs. Okay, let me show this to you. The quality is, the video that I created before had a lot better quality than this one, but this is a little bit more explained, more detailed.
Aluminum, so widely used today, and the world's most abundant metallic element, does not occur in a natural state. The most available source of aluminum is actually bauxite. Bauxite is mainly mined in tropical countries and carried by boat to the Quebec port of La Baie. The aluminum atom in bauxite is bonded to oxygen molecules. These bonds have to be broken by electrolysis to produce pure aluminum. Bauxite is carried by rail to the plant where it will be crushed. Then, through a chemical transformation called the Bayer process, alumina is extracted. This is then roasted in calciners to eliminate all moisture. This is alumina. It is transported by rail to the reduction facility. This plant has 432 pots in which a powerful electric current will be passed to produce electrolysis. An overhead crane dumps alumina into the pots. Then the electric current from the anode placed in the alumina passes through the alumina, which we see here right at the bottom of the pot. Via the process of reduction of the alumina at 950 degrees centigrade, the anodes lose volume and will have to be replaced. It's a continuous operation. Each anode has a lifespan of about 20 days. Spent anodes are recovered from the pot with this overhead crane and carried off to be recycled. They clean the aluminum rods, which will then be reused. Here we see the crust formed atop the anode. When the anodes are replaced, the accumulated impurities have to be recovered from the top of the pots. This is accomplished with these pincers. Then a new anode is inserted into the alumina and electrolysis continues. The electric current breaks the molecular bonds. The heavier aluminum collects at the bottom of the pot, while the oxygen bound to fluorine is released as a gas which is drawn off and treated. The liquefied aluminum remains at the bottom of the pot. It has to be recovered in this huge crucible with a tube. The tube is dipped into the bottom of the pot and a vacuum system draws the molten aluminum from the crucible. The aluminum is recovered in a short time. Air is vacuumed from the crucible by a flexible pipe held by an operator. The tube is finally withdrawn and the overhead crane dumps another quantity of alumina into the pot. Thus, the aluminum fabrication process continues uninterrupted. The crucibles filled with molten aluminum are transported to the casting house. Their contents are poured into holding furnaces which have a capacity of 60 tons. In these very hot furnaces, the molten aluminum is stored to await casting. Finally, casting begins. The aluminum is either semi-continuously vertically cast, producing ingots, sheets, or billets, or directly cast into semi-finished products. The cooling of aluminum pieces is accelerated by water sprays. The large rectangular ingots, which can weigh up to 25 tons, will head for hot rolling, eventually leading to fabrication of products such as aluminum foil. From 4 to 5 tons of bauxite have produced 2 tons of alumina, which in turn produces 1 ton of aluminum. This particular plant produces 200,000 tons of aluminum annually, yet some other facilities can turn out as much as 400,000 tons.
The production of aluminum is quite big. It's a quite big industry, and countries like our country, or, well, tropical countries, they have a characteristic. We have a characteristic that um, we are developing countries. Okay, so what happens in the end? We have we are lucky by having minerals in our soil. Okay, but what happens? There are many other companies that, because they do the investment, they invest in the country. They feel like they have to take our resources away from us. That's why we're still a developing country, and the United States is selling aluminum at all costs. And I wanted to show you that because the process is quite interesting. As you can see, I mean, it's a large process. It's a large process. But the person, or in the end, the one who gains more money from that is the one that produces the final product, the final aluminum, the pure aluminum, not us. We have the appropriate soil here to produce it, but we don't have the technique. We don't have the money to do it because we are a poor country. Is that true? Yeah. Anyway, China is ahead of us in many ways. Well, that was it for the Boron family. This one is quite interesting, the carbon family, because carbon is the most abundant known metal on Earth, and is the metal that is responsible of the organic compounds. Take a look. The carbon family involves all the elements that are below carbon, which are silicon, germanium, tin, and lead. Okay, but this group is like a mixture. Okay, we have carbon, that is a non-metal. Okay, we have silicon and germanium, that they are metalloids. Okay, and we have tin and lead, that are metals. So in this group we're gonna have a mixed properties. Okay, a variety of properties, physical and chemical properties from these elements. They occur in nature. We already discussed this and this. Okay, they occur in nature as free elements or pure elements, or also combined, like the example that we saw about bauxite. Okay, it could be combined or not. They consist of atoms that contain 4 electrons in the outermost level. Exactly what I told you in the boron family. Okay, exactly what I told you in the boron family. If you count the electrons in the outermost level, you will find 4 electrons. 5s2, 5p2, 2 and 2 makes 4. 4 electrons in the outermost level. That is a characteristic that all these elements have. Germanium, 4s2, 4p2. Silicon, 3s2, 3p2. Carbon, 2s2, 2p2. In the end, all of them have 4 electrons in the outermost level. They are relatively unreactive. They are relatively unreactive, and they tend to form covalent compounds. But in the case of tin and lead, that are metals, they can form also ionic compounds. As I was telling you yesterday, an ionic compound is a compound that contains a metal. So in the case of tin and lead, when they combine with other elements, they will form ionic compounds. Now I want that you guys see the picture that I'm projecting here. That element is lead. It's really heavy. Okay, if you see the atomic mass of lead is 207.2. Now compare that mass to the one of aluminum. What is the mass of aluminum? What is
The what, miss?
the atomic mass of aluminum?
13.
That's the atomic number. The atomic mass is 26.981. Now, if you compare it to the atomic mass of lead, that is 207.2, lead is really heavy. That's why it is used for fishing. It's used for fishing, okay? In what we know as plomos. I don't know if you heard, okay? Plomos, they are very heavy. Well, not very heavy according to the size, okay? But they are heavy weights that are used for fishing, okay? For fishing in a pond or even in a river, okay? Lead is using that. And the reason is because it's very resistant to corrosion. So you can put lead in water and it's not going to oxidize. It is very soft. Compared to other elements, lead is a very soft metal. It is highly ductile. That means that it can be shaped into different forms, and malleable, okay? That it can be bent. Lead is toxic, as well as mercury, okay? And it is a poison that could be cumulative. So if a person is working by melting lead to create those weights that I told you, esos plomos que se usan in fishing, okay? Imagine that a person works in that and is not wearing a mask, for example. After many years, that person is going to be poisoned by lead, and that is what is known in medicine. This is known as heavy metal poisoning. Juliet.
My grandpa used to do lead, mister. When he do the plomos, he used to do that, and he do it without the mask, and the doctor tell him that he stop do that.
See my point, right? And I know that because my dad does the same. My dad goes fishing every weekend, and I'm always telling you have to wear a mask. I'm always telling him, ah, trying to deal with other people is very difficult. And now he tells me that he doesn't wear any protection, but he is far from the source. But still, I tell him, still you have to be careful, and that is poisonous. There is a medical diagnosis as heavy metal poisoning, and sometimes that is going to affect your quality of life. So, guys, this is going to be it for today. The homework will be the same homework that I assigned yesterday. You will write 5 characteristics of boron group and carbon group, and also 5 examples of each, okay, in your notebook. Okay, very simple homework.